Alright, let's look at the homework 11.8 problem number 3. Right, so let's find the radius of convergence and the interval of convergence of this given power series. Alright, so this one I'm going to do the ratio test again. So ratio test. Alright, so we have a limit as n approaches infinity. Then you have an absolute value sign. Then you have an, so you have a 2 to the n plus an plus 1, I should say. And then quantity x plus 3, raise it to the n plus 1. And then you have a square root of n plus 1. And divide by an, so I would just take the reciprocal of that guy. So you have a square root of n here. Then you have a 2 to the n. And then you have x plus 3 to the n. Alright, then we can simplify. So you can see that we can cancel here. X plus 3 to the n. And you have 1 extra there. And the same thing here. And you have a 1 extra too. Alright, so what you get is going to be, so 2 has nothing to do with n. And then absolute value of x plus 3 has nothing to do with n. So you have a limit. N approaches infinity. So you have both square roots. So I'm going to put under the same square root. Then n on top. Then you have a n plus 1. Right? Then we can just do the same trick again. So multiply by 1 over n on top. 1 over n on the bottom. Then you would get 2 times absolute value of x plus 3. And then you have a limit as n approaches infinity. And you have a square root of 1 on top and 1 plus 1 over n. Right? And this guy right here approaches 0. So you just have square root of 1 over 1 is just 1. So this whole thing, the limit is going to be 1. So we have 2 absolute value of x plus 3. This is less than 1 since it's a rational, the ratio test. All right, to find the radius of convergence, you have a 2 there. You have to divide through by 2. So divide through by 2 to get the absolute value of x plus 3 is less than 1/2. Alright, so this is the radius of convergence. So 1/2. Alright, so let's start with this inequality. Absolute value of x plus 3 is less than 1/2. Alright, we can turn this into inequalities without the absolute value. So it's going to be x plus 3 is between negative 1/2 and a positive 1/2. Alright, so I want to isolate x. I'm going to subtract 3. So negative 1/2 minus 6 over 2. So minus 7 over 2. And then is less than. Alright, 1/2 minus 3 would be negative 5 over 2. Alright, so we got that. Then we just need to check endpoints. Alright, so let's check the left endpoint. So when x, so I'm going to say left endpoint. Alright, so when x is equal to negative 7/2. Alright, if you plug in negative 7/2, it's going to be negative, so we're going to have this series, right? So you have a summation. N goes from 1 to infinity. Right? You have a 2 to the n, right? So you have a negative 7 over 2. So that's going to be plus 3 would be negative 1 over 2. Raise it to the nth power. Then over square root of n, right? then we can cancel out 2 to the n and 1/2 to the n. So actually 1/2 to the n. So you have a negative 1 to the n on top left. So we get the summation. N goes from 1 to infinity. Negative 1 to the n over square root of n. Alright, then we can just do since this is an alternating series, so we can check, so a bn in this case, 1 over square root of n, and the bn plus 1 is 1 over square root of n plus 1, since denominator is larger and the fraction is smaller. So the first condition checks out. Then we just need to check the second condition as well, but the second condition is very easy to check. 2, if you take the limit of bn, 1 over square root of n, as n approaches infinity, is going to be 1 over infinity, which is 0. So second condition checks out, so we have a convergent alternating series. So this is by alternating series test. Alright, how about let's check the right endpoint. When x is equal to negative 5 over 2. Then we have a summation. N goes from 1 to infinity. So you have 2 to the n. Then you have a negative 5 over 2 plus 3 is just 1/2 to the n over square root of n. Right? So you can see that 2 to the n and 1/2 to the n cancel out, and you get this a simple p-series. So n goes from 1 to infinity, 1 over n to the 1/2 power. Right, so this is the p-series, and p is equal to 1/2, which is less than or equal to 1, which means that this is going to diverge. Right, so this is a p-series test. Alright, so we want to include the left endpoint, so we're going to include negative 7 over 2, but exclude the right endpoint, which is negative 5 over 2. Right, so let's type it in. Alright, radius of convergence is 1/2, and interval of convergence negative 7 over 2 to negative 5 over 2. Alright, so let's check the answer. Submit for testing. Alright, looks like we got the radius of convergence and interval of convergence correctly. Alright, that's it. I hope that this was clear.